Welcome back to the Ductile series of videos. Now in this video we're going to talk specifically about connections between steel elements. Now connections and the way that steel comes together is a very important part of the design thinking around steel, and very clearly the remit of an architect to make sure that it's done elegantly and coordinated well. If we tend to ignore this aspect of the design of steelwork, and often we can if the steel is hidden away, for example. But if we let engineers and so on just take charge of this, we could get quite efficient connections that use less material and so on, but that visually are almost like an eyesore. So we do have to be measured in the way that we design our connections so that they are elegant and efficient, but we never ignore them. Now there's a myriad of connection types, and it would be impossible in this video here to cover all of the potential types, and so what I'm going to do here is just simply explain a handful of different strategies, and from those strategies I guess you can build any number of connection types. Now it's important to recognize that when making connections we do end up having to add elements to the steel. So we weld plates to them so that other steel elements can connect to them. So these cleats and stiffeners and so on are things that we design and things that have to be added in during the prefabrication stage, and something that has to be done right, because we get them wrong, they can't be changed on site. Now here we can see a typical heavy steel post coming down onto a concrete either mass footing or slab. Now one of the typical problems with steel connections to imprecise systems such as concrete and so on is that steel is always quite precise, quite small tolerances, whereas the set out of things like the studs in or the starter bars in concrete is a very imprecise system. So we do need to make tolerance so that the two systems come together well. Now one of the things that we have to do is firstly provide some means of being able to level and plumb the steel elements, and the other is to give a bit of tolerance between where the studs, the starter bars and the steel coming together. So the first thing to bear in mind is that the holes that we create in steel always have to be oversized, so that it gives a little bit of playroom and tolerance for the bolts to come through. The other thing is, particularly with heavy steel, to level up the beam. What we often do is with the starter rod, we thread on some leveling nuts so that the steel can go over the top of that, and then we can adjust the nuts underneath the plate to level it up, and then put another set of nuts on top of it to tighten it up, after which we fill the gap between the bottom plate of the steel and the concrete footing with a fine mortar fill. The other typical steel connection where we get beams connecting to columns. Now often the width or the flange widths of universal beams are not the same width as the flanges of universal columns. So we do have to make sure that we understand the relative dimension between them. Now it is reasonably easy to just have a series of punched holes in a universal column, the vertical elements that we can bolt through. Again, making sure that both pairs of holes in the column and also the end plate of the beam are oversized to accommodate some degree of tolerance. Now, in order to give more rigidity of the bolted connection between the column and the beam, we do end up having to weld in a series of stiffening plates into the column. This prevents deformation or buckling of the flanges under load. So in exposed steel structures, yes, it actually makes it look more aesthetically complete, but at the same time they do serve an important structural function. The other way of connecting is with a beam to a column is to connect directly to the web of the column. Now in this instance, because it's more difficult to get to, you can put an end plate on the beam to fix to the web, but more typically what happens is that there's a tertiary element like a bracket or something like that that is either welded or bolted first to the column, after which the beam comes along and is fixed into it. So those cleats or bolting angles are those tertiary elements, or those extra things that we need to weld on or add to our standard structural elements to make the whole system come together. And in other situations where we're trying to make a moment or a stiff joint at the edges, we can cut and weld two elements together. And in those instances, it's very important that the coordination of the dimension of the flanges is exact, so that the elements are consistent as it moves from a horizontal to a vertical plane. It often means that we end up using universal beam profiles for columns as well, which is common in portals. And again, in order to stiffen the corners and to prevent deformation of the flanges under load, we put stiffening plates where those loads are being transferred. The other thing which we often need to do, particularly with more complex profiles, is, and as architects we can come up with a myriad of different connectors. Now these bespoke solutions can be developed from flat plate and then cut and welded together in a factory. So we can get some quite interesting and quite aesthetically interesting connections that are possible with taking everyday standard profiles and combining them with highly crafted connector pieces at the ends. Now, although often these are more expensive, with economies of scale and with automation, these bespoke solutions in the end are becoming more and more affordable. Well, as I said at the start, it's impossible to cover all of the connection types with heavy steel bolted connections. It is a design exercise and does require the combination of bespoke elements, connectors and end plates with standard profiles and coordinating those dimensions so that the system is thought of three-dimensionally. So hopefully you'll be able to take on some of this and build on that through your design exercises. Thanks again for listening.